Hey everyone, in this video lesson you will learn how to find zeros and graphing polynomials. Okay, so we're going to find zeros and then sketch the graph. So for example, number one, I'm going to set the y equal to 0, and then there's a GCF in these three terms, and that GCF is x itself, right? So then x is a GCF, then this becomes x squared, and then this becomes 3x, and that becomes a just 2, okay? So now once we get to this point, we're trying to find the multiples of a times c, which is 1 times 2, that add up to 3. Well, that's an easy one, because the multiples of 2, that when you add them give you a 3, is 1 times 2 itself. So then this factors as 0 equals x times x plus 1 times x plus 2. Then set each one equal to 0, which means x equals 0. And for this one, x plus 1 equals 0. Let's see, so x plus 1 equals 0, and then x plus 2 equals 0. So for this one, x equals -1. That's this one here. And for this one here, x equals -2. Okay, so those are the solutions to this polynomial. Next, I'm going to sketch the graph. So here we have the x-axis and the y-axis. So we have solutions that, let's say this is -1, and this is -2, and this is 0, right? I know it's not drawn to scale. So we don't have doubles, triples, we just have singles. So we have intersection of the x-axis at this point, at this point, and at this point. There is no negative lead coefficient, so that means the right-hand behavior is up. Since the degree is odd, then if the right-hand behavior is up, the left-hand behavior has to be down, right? Because they go in opposite directions. So then it's going to cut through x equals -2, then turn and cut through x equals -1, and then turn and cut through x equals 0. And this is what the graph looks like for this example, okay? So let's move on to the next example. Set the y equal to 0. Then there's a GCF of x squared, so I'm going to factor it out. So now this becomes x squared minus 2x minus 15, okay? And now we're trying to find the multiples of a times c. A is 1, c is -15, so multiples of -15, that when we add those multiples, they add to our b value of -2. Well, that's 3 times 5, right? But we need a -2 when we add them, so that means the 5, it's minus, and the 3 is positive, okay? So then coming back here, we have 0 equals x squared times x minus 5 times x plus 3, okay? And as you can see, we have already one solution here, which is x equals 0, and this is squared, so that means this solution is a double solution. And then x minus 5 equals 0. So if I set x minus 5 equal to 0 and I solve for x, then that means x equals 5. And for this one, if I set x plus 3 equal to 0, I subtract 3, which means x equals -3. Okay, so we have, I forgot to box in these solutions here. So we have a double at x equals 0. I'm boxing in the whole thing. You don't have to, okay, just box in your solution. So that's right, that's fine right there. And then for this one, I'm just going to box in x equals -3. And now let's sketch the graph. So here again is the x-axis, and we need -3. And so let's say this is -1, -2, -3. And then we need 1, 2, 3, 4, 5. Again, notice this is not drawn to scale. We're just trying to get a visual of the problem here. So we have intersections of the x-axis at x equals 0, and at x equals 5, and also at x equals -3. Okay, so this one is single, this one is single. Degree is even, so the ends should be going in the same direction. Since the degree is even, that means, and also we don't have a negative lead, so on the right they should be going up, and then on the left they should also be going up. Okay, because again there's no, they go in the same direction. So then at x equals -3, we have a cut. It's going to cut through the x-axis, then turns and gets to x equals 0, and it's going to bounce because that's a double solution. And then turns again, and cuts through x equals 5. So this is what graph looks like for this problem. Okay, so let's move on to the next example. For this one here, let's set the y equal to 0, and then let's see if there's a GCF. They do have 2 and x in common, so let's factor out the negative lead. So this is 2x. Now this becomes x squared minus 7x instead of 14x squared minus 10. Okay, so now find the multiples of negative 10, because a is 1 and c is negative 10. So when you multiply 1 times negative 10, that gives you negative 10. So find the multiples of negative 10 that when you add them, they add to your b value of negative 7. Well, that's an easy one, because that's 2 times 5. And that means, let's see, that means they both have to be, oh, I made a mistake here. Notice I factor a negative. This should be negative. So let me change the sign of the 10. I was like, this doesn't make any sense. Okay, but there it is. You can always check to see if what you're doing is correct or incorrect. So then that means that they both have to be negative. So then coming back to this, 0 equals negative 2x times x minus 2 times x minus 5. Okay. Then next you set each term equal to 0. So we have negative 2x equals 0, x minus 2 equals 0, and x minus 5 equals 0. So then for this one, divide by negative 2. So x equals 0 is one solution. And this one, add 2 to both sides of the equation. So x equals 2 is the other solution, or another solution. And then for this one at 5. So x equals 5 is the third solution. Notice there is no double or triple solution. They're all single. So when they go through the x-axis, they're going to cut through the x-axis. Okay. So again, let's sketch the graph. So this again is the x-axis, and we need positive numbers for x. So that means we don't need much of the left side of the x-axis. So this is 1, 2, 3, 4, 5. Again, this is 2 and this is 5. So we have intersections at 0, at 2, and at 5. But now let's go back and look at this. We do have a negative lead, and the highest exponent is odd. So that means the end's going opposite directions. So then at 5, they should be going down. And at 0, they should be going up. Okay, and again, they're all cuts because they're single solutions. So it's going to come down here, cut through the origin, then turn, cut through that x equals 2, and then turn again and cut through x equals 5. So that's what the graph looks like for this problem. So one last example on this lesson. Okay, for the last example, again, we set the y equal to 0, and then let's see if there's a GCF. 3, 2, and 8 do not have any factors in common, but they do have an x in common. And the highest we can factor out is x to the second. So this is x squared as a GCF. Then this becomes 3x squared minus 2x, and then minus 8. Okay. So then now we see that a is not equal to 1, it's equal to 3. So then multiply 3 times negative 8, which is a times c. So then we find multiples of negative 24, that when we add those multiples, they add to a b value of negative 2. But don't forget, this is factoring by grouping. Okay. So the only multiples of negative 24 that add up to a 2 are 4 times 6. So 4 times 6 gives us 24, but one of them has to be negative, and that is the 6 has to be minus. Okay, so then coming back here to finish factoring this out, 0 equals x squared, and then 3x squared. I'm going to group the negative 6x with this, so minus 6x, and then plus 4x minus 8. And again, we use factor by grouping here. So if I group these two terms together, they have a GCF of 3x, and these two groups have a GCF of 4. Okay, and it's a plus 4. So then we have 0 equals x squared, and then open parentheses, we have 3x, the GCF of the first group. Then this becomes x, and negative 6x divided by 3x is minus 2, plus that 4 is a GCF on the second group. 4x divided by 4 is x, and negative 8 divided by 4 is minus 2. So now we have the same binomial, or the same linear factor in the two groups. So then 0 equals x squared times x minus 2 times, put together, 3x plus 4. and this is factoring by grouping. We're done factoring. So now let's solve. Okay, so the last step is we're going to solve each one of these terms. So we have x squared equals 0, which means x equals 0, and this one is a double solution. And then for this one here, we have x equals 2, and for this one, we got to work this one out. So 3x plus 4, unless you can do it mentally. Subtract 4. So then we have 3x equals -4, then divide by 3. So x equals -4/3, which is approximately in decimal form, -1.3. Okay, so we have this solution here that is a double, this is a single, and this one is also a single. So keep that in mind when we sketch the graph. So now let's sketch the graph. So we need, let's see, we need 0, 2, and -1.3. So let's say this is the y-axis. This is -1, this is -2. This is +1, +2. So we have intersections at -1.3. So let's say approximately right there at x equals 0 and at x equals 2. Okay, so from here, we go back and look at the degree. Degree of the problem is even, so that means the ends go in the same direction. Lead coefficient is positive, so they both point up. So right up, and left side is also up, the end behavior. So then at x equals -1.3, it's going to cut through it because it's a single solution. But then at x equals 0, this graph turns, hits that point, bounces off of it, then turns and cuts through x equals 2. And that is all for this lesson. I'll see you guys in class. Bye-bye.